Hello students, I am Ashish De. I am taking one of your subject, that is digital signal processing. In my earlier video, I have taught about discrete time signal, definition of discrete time signal, difference between continuous time signal and discrete time signal, representation, various kinds of representation of discrete time signal, and some discrete time test input signals. Okay, now in this video I want to teach about classification of discrete time signal and their mathematical calculation. Okay, so first classification of discrete time signal, there are first is energy signal and power signal. So first, energy signal and power signal. As we know, any discrete time signal is represented by x of n. What is the name of n? That is discrete time index. Okay, so for any signal xn, the energy E can be calculated by this formula. Energy E is equal to summation of n equal to minus infinity to infinity mod of xn whole square. So this is the formula to calculate the total energy of any discrete time signal xn. Okay, and average power of this signal can be calculated by using this formula. Limit capital N tends to infinity 1 by 2n plus 1 summation of small n equal to minus capital N to capital N mod of xn whole square. So there are some similarities between two formulas. Just notice here the range of n in the summation is starting from minus infinity to infinity, but in case of power, the range is from minus capital N to n. So here one extra term is multiplied, that is 1 by 2n plus 1, and there is a limit where capital N tends to infinity. So these are the two formulas to calculate the total energy of any discrete time signal xn and average power of the discrete time signal. Now, what is the definition of energy signal? A signal is an energy signal if and only if. So this is the necessary condition: if and only if the total energy of the signal is finite. Okay, so for energy signal, E should be finite, that means E less than infinity. Okay, but for an energy signal, the average power P will be 0. Okay, so if these two conditions are satisfied, then a signal in xn can be called energy signal. Again, to calculate power signal, any signal can be called power signal if the average power of the signal is finite. Okay, so for power signal, T should be less than infinity. Okay, and for a power signal, the energy of the signal will be infinity. So these are the two conditions to check whether a signal is power signal or energy signal. Okay, let us take an example. Suppose this is example number 1, ex1. Okay, where the signal is given by xn equal to 1 by 3 to the power n into un. This is the discrete time signal given. Now we have to first calculate, we have to check whether this signal is energy signal or power signal. Okay, so at first we have to calculate the total energy of the signal. So total energy of the signal E can be calculated by this formula, n equal to minus infinity to infinity mod of xn whole square. Okay, now xn is given by this. Here a term un is multiplied with 1 by 3 to the power n. What is un? All of you know that un is an unit step function. Okay, un is defined for un will be equal to 1 for n greater than equal to 0 and 0 for n less than 0. So this is the definition of un, unit step function. Okay, so if a unit step function is multiplied with any quantity, that means the total signal has the range from n greater than equal to 0. So it has the value for n greater than equal to 0, otherwise it is 0, because 0 is multiplied with any number will be 0. Okay, so the range of the summation will change from minus infinity to infinity to n equal to 0 to positive. So here the signal is given by 1 by 3 to the power n into un. In this range the value of un is equal to 1, because here un equal to 1 for n greater than equal to 0. Okay, so here is un equal to 1. Okay, now the formula is mod of this thing whole to the power 2. Okay, so this will be equal to n equal to 0 to infinity 1 by 9 to the power n. So if you expand this series, it will be 1 plus 1 by 9 plus 1 by 9 whole square plus up to infinity. Now this is a GP series where the value of r is 1 by 9. What will be the formula to calculate this the value of this series? That is 1 by 1 minus r, that is 1 by 1 minus 1 by 9. Okay, so this will be equal to 9 by 8. So this is finite, this is the finite value. So here energy E is finite. Now we have to check whether the average power of this signal is 0 or not. So the average power of this signal can be calculated using this formula. Limit n tends to infinity 1 by 2n plus 1 summation of small n equal to minus capital N to capital N mod of xn whole square. So this is the formula to calculate the average power of the given signal. Okay, so here will be limit n tends to infinity, so it will be 1 by 2n plus 1 summation of, here the value of n will be starting from 0 to capital N, because there will be no values of xn for the negative values of small n. Okay, so it will be 1 by 9 to the power n. Okay, so it will be limit capital N tends to infinity 1 by 2n plus 1, and the value is, if you put here 1 plus 1 by 9 whole square up to plus 1 by 9 to the power capital N. Okay, this is also a GP, finite GP series. Okay, so if we find the value of this series using the formula, it will be 2n plus 1, and it has the value 1 minus 1 by 9 to the power n plus 1 by 1 minus 1 by 9. Okay, So because we know a plus a r plus a r square plus up to a r to the power n has the value a into 1 minus r to the power n plus 1 by 1 minus r. This is the formula when mod of r less than 1. Here is mod of r less than 1, so this is the formula. Now it will be equal to 9 by 8 limit n tends to infinity 1 by 1 by 9 to the power n plus 1, this thing, divided by 2n plus 1. Now if you put limit n tends to infinity here, this portion will be 0 because 1 by infinity, that is 0, and here is also infinity, so 1 by infinity, that is also 0, so the result will be 0. Okay, so in this case the energy, total energy E is finite and power P is 0. So this is basically an energy signal. So the signal is an energy signal. Okay, so these are the steps to find out whether a signal is energy signal or a power signal.